Hello everyone, my name is Engineer Angad Singh Kalsi and welcome to my YouTube channel. So guys, in today's lecture, we are going to study about the basics of design of machine elements. So now let's have a look over here. So basically, what is a machine?
What is a machine?
It's a very popular dialogue from the movie Three Idiots. So here I define that a machine is defined as a combination of many parts or machine elements which are assembled to perform a specific task. Now by that, what I basically mean is that there are many parts or small machine elements which are grouped together to make assemblies, and these are probably your sub-assemblies which are then further combined into assemblies, and then it is termed as an entire machine. If we consider that there is a machine, then it would probably have assemblies. Okay, and now these assemblies would have, for suppose, sub-assemblies. So there are n number of sub-assemblies depending upon how complex our machine is. Now within these sub-assemblies, we would have something called as a machine element or a part. Now so on, we can also categorize that these machine elements would also have some number, right? Because these finite sets of machine elements, when combined with the various sub-assemblies, would give us a super assembly, and that in turn is a machine, and that performs the task which we were supposed to get out of it, right? So I would like to talk about a very basic assembly in general. Okay. So over here I'll not talk about assemblies. I'll just talk about the term assembly. Okay. So for suppose this can be of two machine elements or two parts, which is nothing but a nut and a bolt. Okay. You can see that there will be some threads, right? This will also have some threads, right? Just to conceptualize, I'm drawing like this. This is the center line, okay, imaginary one. So this is our nut and this is our bolt. So when we combine the nut with the bolt, we can see that the nut rotates around this axis on the bolt and it goes inside. So this particular portion of the bolt is called as head, and this portion of this bolt is called shank. Okay, so basically when we thread this nut onto this bolt and if we place some object in between, so when we thread it, so it helps us to form a fastener assembly. Okay, So in a fastener assembly is basically used for joining parts together using the nut bolt assembly. This is the basic assembly, also known as fastener assembly. So now we will move to a bit complex topic over here. So I have considered a machine which you use in daily life when you are feeling stressed or anxious. You play with this fidget toy called fidget spinner. So if we look at this fidget spinner, it is also a marvelous piece of engineering. So basically it also has sub-assemblies. So for example, if we consider this fidget spinner in front of us, so the arms, wings, lobes can be considered as one part, right? This entire body which you are seeing, which is revolving around this, consider this to be axis, it's revolving around the axis. So this arms, wings, loop itself is a part. And then we talk about the weights, which are these balls which are put inside these arms, which are pierced inside these arms. They are like 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So which makes the total part till here around 6, including this wings, right? So now we talk about the plastic coverings which are there. So these are the two plastic coverings which encompasses a ceramic bearing. So this is 7 and 8, the up and the down part of this particular fidget spinner. The factory has designed it in such a way that when it is pressed, it is tightly pressed such that it cannot be removed back, and it keeps the ceramic bearing in the place, and it maintains the stability of fidget spinner. Now when we talk about the machine elements which are involved in the ceramic bearing, it's a bit complex topic because ceramic bearing itself is an assembly. So now we would explore more about the topic in depth using the computer. Okay, so just now we covered the simple fastener assemblies. In that we covered the nut and bolt assembly in the previous lecture which we were discussing on the board. So here there is example of the nut and bolt with the two plates, which is the classic assembly where the two plates are joined with a bolt, nut and a washer. So as you can see that there is a bolt and nut and a washer. This is classic. Now here you can see that there is a riveted joint. So in this there are basically two plates that are permanently joined with the help of rivets. A riveted joint is a permanent fastening method where two or more plates are joined using rivets. Holes are drilled in the plates, rivets are inserted, and the ends are hammered to form heads that clamp the plates tightly. Such joints are strong in shear, widely used in structures like bridges, boilers, ships, aircrafts, where reliability is very critical. So as you can see here in front of us, there are basically two plates which are joined with the help of a rivet. But possibly there is a chance of that this particular riveted joint can fail because of shear failure that can occur. Now we will talk about the motion transmission assemblies. So in here, basically gears and sprockets are the machine elements that are used to transfer motion and power from one shaft to another. A gear has a teeth that meshes with one another's gear's teeth, ensuring no slipping. For example, in a clock where small gear transfer motions from the spring to the hands. A sprocket looks like a gear but works with chain, as seen in a bicycle where the pedal turns the sprocket, which drives the chain and rotates the rear wheel. Both are used to change speed, torque, or direction of motion. A small gear driving a big gear reduces speed but increasing torque, while a big gear driving small gear increases speed but reduces torque. In short, gear and sprockets act as the translators of motion. So here we can see that there is a gear. There are basically two gears which are meshing with each other. And when we talk about these, so a 3 is to 1 gear ratio can be obtained when a 20 tooth pinion meshes with a 60 tooth gear if the module M of the gear is chosen as 3 mm. The pitch circle diameter of the pinion becomes 60 mm and that of the gear becomes 180 mm. In this case, the pinion rotates 3 times for one rotation of the gear, reducing speed while multiplying torque by 3. The gear teeth are cut in an involute profile where the addendum is approximately equal to one module 3 mm. The dedendum is about 1.25 times the module 3.75 mm and the total tooth depth is about 6.75 mm. Now we will move on to the sprocket. So basically, as we can see, sprocket is a very common mechanism in bicycles. So in this, basically we can see that there is a roller chain which is connected to sprocket, which is driven by the pedal gear, which is the driver. Now, if we look at the roller chain itself, it itself is a very interesting machine element. A roller chain is made up of several basic machine elements, including the outer plates, inner plates, pins, bushes, and rollers. These elements combine to form sub-assemblies. The outer link, pin link, which consists of two outer plates and two pins, and the inner link, which is the roller link, which includes two inner plates, two bushes, two rollers. The complete chain assembly is created by alternating outer and inner links in sequence, resulting in a flexible chain that smoothly transmits the motion over the sprockets. Now we will study about the energy storage machine element, which is basically spring. So when we talk about the types of spring, before that we will define what is a spring. So a spring is a machine element that is designed to store mechanical energy when deformed, and it releases that energy as it returns to its original shape. So we will talk about the different types of spring. So basically, when we talk about the helical compression spring, it is a coiled wire spring that resists axial loads and stores mechanical energy. When we talk about the garter spring, it is a circular helical spring used to maintain tension in a seal or hose. When we talk about the helical extension spring, it is a spring that stretches under load having hooks or loops at end. Talking about the coil spring, it is a very classical type of spring, which is a cylindrical spring that absorbs shock as it supports weight in machinery or vehicles. When we talk about the torsion spring, it is a type of spring that twists about its axis to apply torque or rotational force. When we talk about the spring belt is a belt reinforced with embedded helical springs for flexibility and strength. When we talk about leaf spring is a laid flat spring used in the vehicle suspension to absorb the shocks. When we talk about the oil seal spring, it is a small spring used inside oil seals to maintain lip contact and prevent leakage. Now, using the FreeCAD parametric software, we will create a 3D model of the per gears of 3 is to 1 gear ratio meshing with each other. In the end, I would like to say if you found my video informative, do share it with all of your friends and don't forget to subscribe to my channel. I would be uploading more lectures on my YouTube channel. Thank you.